hey Khal, I see you there, man. What you doing there? Just reading a book. Just a book? Well, do you know what electricity is? I just found out about it from Mrs. Fowler. That's interesting. So, energy. Basically, electricity is energy, which comes from a form of charged particles, statically or dynamically, which is uber vicious. So what do you call power failure?
I don't know.
A current event. Knee snapper. A neutron walked in the bar and said, "Hey, how much do you charge?" And the bartender said, "For you, no charge."
Hello there, fellow citizens of the United States. It is my mission today to inform the public and the young generation about the necessity and the importance of understanding how electricity works. I have one simple message. Electricity or death. Let me educate you. Electron was created by J.J. Thomson. It was created by using a cathode ray to shoot particles in very low pressure. Next, the proton was created by Ernest Rutherford. He created the proton by throwing hydrogen atoms at the gold foil. Last, James Chadwick created the neutron. This final key to the atom was discovered by figuring out that there was added weight to an atom for no reason.
Where does bad light end up?
I don't know.
In a prism. So what was the name of the first electrical detective?
I don't know.
Sherlock Holmes.
The electron is found in the electron clouds surrounding the nucleus of the atom. The electron is a negatively charged particle, and its weight is so small that it's typically not counted in physics. The nucleus of the atom is made up of protons and neutrons. Protons are positively charged particles, and neutrons have no charge. They weigh about the same, and they make up the mass of the atom.
So you're probably wondering, how does electricity work in your house? You know, like, how is that working over there? Yeah, you gotta think electric currents. Electric currents are the reason why this world is going into the future. Your iPhones, your Wii phones, your phones, your galaxies, everything. Thank you, electric currents. Electric currents are basically wireless inside your own house. They transfer electrons all over everything, including your light bulbs, your TVs, your stoves. If you have electric one. Thank electricity. Thank electric currents.
Oh my god.
So let's break this down a little more. Most of you know how to charge by contact because you do it all the time. Ever shocked a sibling? Ever rubbed a balloon on your head? Well, this is charging by contact. This is the one you are most familiar with and probably enjoy the most also. Balloons are a great easy example of this, but there are other good conductors also. A balloon is a conductor, or a body that serves as a channel for electricity. There's actually a lot happening behind the scene of this simple, silly experiment, so let's take a closer look. So before we get into negative and positive charges, let's make sure we know what conductors and insulators are. A conductor is something that lets electrons flow through it easily. An insulator won't let electrons flow through it. This is what makes some objects, like a balloon, able to rub onto your head and you see a visible result from it. The red pluses you see are protons. The blue negatives you see are electrons. Only the electrons are able to move from object to object. If an object has more protons than electrons, pluses than minuses, it has what we call an overall positive charge. And if it's the other way, having more electrons than protons, it has what we call an overall negative charge. So here we have a wool sweater, a balloon, and a wall. As you can see, the balloon is going to be our conductor here. We try rubbing it on the wall, nothing happens. This is because the wall is acting as an insulator, keeping the charges from moving over to the balloon. When we rub it on the sweater, though, we can see the electrons start to move. They move over onto the balloon because of our method of charging, this current one being contact. As we continue to rub the balloon, we build up a big negative charge on the balloon. Let's see what happens when we move it back to the wall now. When it reaches the wall, you can see that the electrons in it move away from the balloon. This is the interaction between like and unlike charges. You've all probably heard that opposites attract. Well, as you can see here, this is true. The electrons in the wall move away because they are repelled by the balloon. If we let go of the balloon, though, it will float back to the sweater, attracting to the protons. This is why magnets and their polar ends also work. There are also two other kinds of charging besides contact: induction and polarization. Induction is charging an object without actually touching the object to any other charged object. You might be able to stick your finger close to somebody after rubbing it on your head and shock them. This is a small example of induction. Polarization works different also. It separates opposite charges within an object. This is also why the electrons in the wall moved when we got the balloon near it.
So, what is the electrician's favorite ice cream?
I don't know.
Chocolate. So why did the gardener plant a light bulb?
I don't know.
He thought he would get a power plant.
Electricity can run in a circuit, which is a closed loop of wire. With it has a switch and resistors in it. And a series circuit is just one of those loops. Parallel circuits are something else.
Parallel circuits are better than series circuits. While series circuits have one path for the electrons to go through, parallel circuits have multiple paths. If we take these lights, for example, these lights, if one of these light bulbs will go out, then the rest will go out too if it was in a series circuit. With parallel circuits, all these lights will stay on if only one went out. So that's the benefits of a parallel circuit.
Here we have a simple series circuit. Most of you guys probably know what Minecraft is, so we'll show it this way so you guys hopefully understand it better. We have a switch and a trail of wire leading to a light bulb. When the switch closes the circuit, it powers the light bulb, sending the electrons down to it, as you can see. Now, unfortunately, in a series circuit, if any part of the wire leading to the light bulb breaks, it will open the circuit, making the light turn off. This is where the next kind of circuit comes in: parallel. Here we have 3 light bulbs, all getting power. If the wire to the middle light breaks, only that one is affected. This lets the other lights stay on and continue working fine. If the parallel circuit gets even more intricate, then sometimes wires that break won't have an effect on the lights at all. Circuits can be very simple or very complicated, but this is the basics behind them.